Hello there, students. In this video we are going to be talking about how to balance equations. So here we have the standards that go along with this. Standard 7 and 8 from the physical science goes along with it. The basic idea is we want to explain and show how molecules and compounds react in balanced chemical equations to form new products. That's what our goal is. So the rules for balancing equations, the main three are there's the bell. Do not change the formula. Do change the coefficients in front of the formula, or in the spaces on the formula, and then simplify or multiply the equation. Very rarely will you have to multiply it, but that sometimes is a helpful trick. The counting atoms rules, you should have watched the counting atoms video, but it reminds us that the subscripts tell us the number of atoms in something. A parentheses plus the subscripts will tell us how many ions there are. A number of ions. Normally, when you have a parentheses plus subscripts, you're going to be multiplying numbers. And then the coefficients will tell us the number of compounds we have in something. Again, that's a hint that we multiply. If we're looking at the reactants or the products, normally the reactants, everything will have separated, each different compound will be separated by a plus sign. And if there's O's or oxygens or hydrogens on either side of the plus sign and you're trying to count the total of reactants and products, that's the only time that you would add. So let's look at the method that we're going to use. We're going to use the Cliff method, as I've described it. It's going to list the reactants versus the products. So what we do is we start by drawing a cliff on the left for the reactants, and then we draw another cliff on the right for products. And then in the middle we list all of our elements. C, H, and O are the things that we have on the left. They happen also to be the stuff on the right. The cliff represents the running total. Whenever you change a coefficient, you have to change all the counts. So we start by listing each of the elements. We have 1 carbon, 4 hydrogen, and 2 oxygen. On the other side we have 1 carbon, 2 hydrogen, and 3 oxygen. That's what we currently have at this point in time. As we look and we see there's a difference between hydrogens, we're going to try and get the hydrogens on the right to equal the hydrogens on the left. The products need to equal the reactants. The only way to do that is to plug in a 2 for the coefficient, saying I want 2 compounds of H2O. If I change that, put a coefficient in there, I have to change all the elements after it, which would be hydrogen now changes to 4, because we have 2 times 2 is 4. And then oxygens, I have 2 over here plus 2 over here. So this is one of those examples where you add, but you first multiply this one, and then you multiply 1 times 2. And we find that we get 4 oxygens. On the other side, the oxygens aren't equal anymore, so I have to plug in a 2 in front of the oxygen on the reactant side to give us 4 oxygens in the reactants. I look and I see that they're both balanced, so I know this equation is complete. Another example, we have Ag, I, Na, and S. Reactant side, draw my cliff. Product side, draw a cliff. Ag has 1, I has 1, Na has 2, S has 1. On the other side, Ag has 2, S has 1, Na has 1, and I has 1. So the Ags we can see right off the bat aren't equal. If I plug in a 2 on the left hand side, it's going to change the Ags. And since I've changed this one, I have to change the I. Oh, the I is now 2. And since I just changed the I on the left, it's best if I stick with that and fix the I on the right. To fix the I on the product side, I need to plug in a 2. It's going to change that to 2, so those equal. And it also changes the sodium to 2 as well. So I have 2, 2, 2, and 1, 2, 2, 2, and 1. Here we have another one, similar to the first problem we did. It's only C's, H's, and O's, so it's another combustion reaction, which you can learn about in the types of reactions video. On the left-hand side for reactants, I have 2 carbons, 6 hydrogens, 2 oxygens. On the product side, I have 1 carbon, 2 hydrogens, 3 oxygens. I'm going to start with the carbons, try and get those close to each other. Actually, we'll start with the hydrogen. I want to get the hydrogens as close as I can. So I need to get 6 hydrogens on the product side, and the only way to do that is to multiply 3 sets of H2O. That would give me 6 H2O, and that gives me a total of 5 hydrogen. Okay, 5 hydrogen because I get 3 from the H2Os, and I get 2 from the CO2. We want to fix the carbons. I'm going to plug in a 2. That's going to change carbon to 2, but it also changes our oxygen. I have 4 plus 3 giving me 7. At this point we know that 2 and 7 need to equal each other, but if I have a 2 in the compound, I know that I'm going to have to multiply by 3.5. Now 3.5 isn't an equal number to have in here. I can't have something that's a half number. All the coefficients have to be whole numbers. However, since I know that this is the only one, if I change that, that would fix this to 7. Since this is the only one that is wrong, or is a half, if I multiply all of the equation by 2, it should equal out. So we're going to switch colors here. We're going to show that, we'll use yellow. We're going to say this one is now 2, change that to 7, change this to 4, change the hydrogen or the water to 6. We'll do a recount of our atoms. Have 4 carbon, 12 hydrogen, 14 oxygen. On the other side, I have 4 carbon, 12 hydrogen, and 14 oxygen. So we can see this one works, and that was a shortcut that we used, changing the 3.5, multiplying everything by 2. So that's a shortcut that we can use. We have 2 more equations. At this time we're going to work on the last 2. Draw my cliff. Silicon, chlorine, hydrogen, oxygen. The other side, same thing, silicon, oxygen, hydrogen, chlorine. 1 S, 4 Cl's, 2 H's, 1 O, 1 S, 2 O's, 1 H, 1 Cl. The Cl's are the farthest apart, so I'm going to start with those. I'm going to plug in a 4, changing the chlorines to 4 and the hydrogens to 4. Now I need to get 4 hydrogens since I changed the Cl, and now the H's are off since the H's and Cl's were combined. I'm going to next go with the H's. H's, I need to get 4, so I plug in a 2 in front of the H2O, giving me 4 hydrogens and now 2 oxygens, and we know that they're both equal once again. The last one, we're going to use another trick. This is what I like to call the blob method. You can see that SO4 is all contained on one side, and then on the other side SO4 is also still contained. It doesn't change. I call those things that stay on one side and move to the other side without changing blobs. They're not really blobs, they're actually polyatomic ions, but the polyatomic ions are easier to deal with if you treat them as just a variable, like an x if it were a math equation. So SO4 is one thing. So when we count up my atoms, I have 1 iron, 2 hydrogens, and 1 set of SO4 on the left side. On the right side, I have 2 irons, 2 hydrogens, and 3 sets of SO4 based on the parentheses and the subscript. Start with balancing the SO4s, getting those the same. I need to plug in a 3 in front of this compound. That's going to give me 3 sets of SO4, but 6 hydrogen. Now my hydrogens are off, so I'm going to switch back to the other side. If I plug in a coefficient of 3 in front of the H2, it's giving me 3 sets of H2, which equals 6 total H's. And now iron is the only thing separated or off, so I plug in a 2, and we get the irons to equal out. So that one is balanced now as well. 263, 263. So here's some of the tricks. Use the power of blobs. The first blob, this equation is going a little overboard with the amount of blobs. There's NH4 is one blob. There's 3 of them there. PO4 is another blob. There's 1 of them. PB is an element, lead. NO3 is another blob. There's 4 of them based on the subscript. PO4 on this side has 4. NH4 has 1. And then NO3 has 1. So that's just looking at trying to separate which ones are blobs. If you use those and keep those the same inside of your cliff, it helps with balancing out. Second trick is to take time with the odd numbers. If you notice you have a 2 here and a 3 there, normally you just find the least common denominator. So you'd say that we need to get 6 oxygens. The other thing to be careful about is with the whenever you have combustion reactions where one element splits into 2 different sets, we have oxygens here. So the oxygen splits from O2 into an O and another O2. So this is going to be, you're going to have to be careful about how to balance that. Actually, that would be one where you use the trick to multiply, because you're probably going to have to multiply this to get, because this will most likely be an odd number, or not a whole number. You get something like 3.5, which is what we got earlier. So we just know that we multiply all of our coefficients. Another choice is to start with the biggest differences. Whatever the one is the furthest apart, generally you start with that. The other trick is to follow a specific order. If I start with changing the PBs on one side, I want to also, after I fix the PBs, if I fix the PB from this side, or sorry, fix the PB on this side, the next thing I want to do is work with the NO3. So I want to work with pairs and try and balance 2 out at once if possible. The last trick is to keep trying. This is not necessarily an easy skill. It takes a lot of time, it takes a lot of practice, but the more you try, the more likely it is you'll get it. If you sit there going back and forth 5 to 10 times on one problem, you might want to just stop, erase everything, and restart over, because it's possible that you just miscalculated, and if you start multiplying after that calculation, it's just going to throw you off more. So this is how to balance equations with some of the tricks and shortcuts for that. Enjoy!